Yes.
So this was the basically topic that we had covered. Vapor pressure. Vapor pressure, basically, what is vapor pressure? Pressure exerted by vapor, or you can specifically called water vapor. If water is present there, then it is called vapor pressure. And we also know what which molecules evaporates or exert pressure first. Or you can see there are two types of molecule here: the surface molecules or the bulk molecules. Surface molecules are the one which evaporates because they have high kinetic energy. And where does this kinetic energy comes from? The heat you are giving to the uh, molecules. And if they have high kinetic energy, they will have low force of attraction. Is this clear up to this? Hamza, is there any doubt?
No, sir.
Okay. Now, write a topic. Wait a minute. Factors on which vapor pressure depends. Factors on which vapor pressure depends. So basically, there are two factors on which vapor pressure depends or does not depend. So the first factor is basically whatever is the size or shape of container, it doesn't depend on it. That means it does not depend on shape or size of container. Like if you have kept the solvent in this type of container or in this type of container or in any type of shape or size of the container, it will not depend on the shape or size. Second, which is very important, is it depends upon nature of substance. It depends upon nature of substance. Mainly vapor pressure depends on nature of substance. Basically, you can understand like this: if you have a particle A in a container this A, and you have a particle B in container B. So see, if the intermolecular force of attraction of in A is high, it will take more time to evaporate as compared to B. Are you getting my point? If force of attraction in A is greater than force of attraction in B, which one will evaporate first, A or B? What do you think?
Sir, I think A.
Again, I'm going to ask the question, same question. Force of attraction in A is high than B, higher than B. Which one will evaporate first, A and B, A or B?
Force attraction means it's
Just see like in this container, there are particles of AAA, and the force of attraction between AA particle are very high as compared to BB
sir,
particle.
B, because in that force of attraction is less, so they're not
It will
very
be,
tightly together. They'll just
yes, yes.
evaporate.
That means it will the bond between BB particle will break easily, and it will evaporate easily as compared to A. Are you getting my point?
Yes, sir, because yeah.
Yeah, yeah. Now see, basically it depends upon the nature of substance. That means the force of attraction in which the force of attraction is higher, there will be lesser vapor pressure. Can I say this? If force of attraction is higher, that means vapor pressure will be lower. So there is a question: vapor pressure of C2H5OH. and vapor pressure of H2O. In which case it will be vapor in case of C2H5OH and H2O, which one will have higher vapor pressure? What do you think?
Um,
If you don't have any idea, let me know.
no, sir, I don't know.
See, if we are talking about vapor pressure, then vapor pressure of ethanol is higher. How can you say that? There are two reasons you can say, because water is boil or evaporate at 100 degrees centigrade, and C2H5OH, I think 60, around 60. It is around 60, 68, or between 60 or 70 it is. So which one will evaporate first? This one, because its boiling point is lower. Are you getting my point, Hamza?
Yes, sir.
Now see, another point which you can think of from class 11th, hydrogen bonding. Are you aware of hydrogen bonding?
Yes.
Now see, C2H5OH has hydrogen bonding, as well as H2O has also hydrogen bonding. But in case of H2O, it makes 4 hydrogen bonding. And here, 1 or 2 hydrogen bonding. Basically, here is lesser hydrogen bonding than H2O. So basically, due to more hydrogen bonding in water, the molecules in water, the particles in water are attracted tightly or attracted very high. Are you getting my point? That's why
They're bonded.
it has yes, bonded very tightly. That's why it has higher boiling point. That means it has higher lower vapor pressure. It has lower vapor pressure. Are you getting my point?
Yes, sir.
So this is it, due to hydrogen bonding. That's why I wrote here nature of substance. That depends upon the nature of substance. So please write it, and then we will have a question on this, and then we will move to the
Okay,
next
sir.
part. Let me know when you are done with this.
Okay, sir. 1 minute. Done.
Very good. Now see, I'm going to give you a question. Arrange in decreasing order of vapor pressure. Arrange in decreasing order of vapor pressure. So the question is basically ethanol. I'm taking ethanol first, then glycol, CH2OH, CH2OH, glycol, and then glycerol, CH2OH, CHOH, CH2H. This is ethanol. This is glycol. This is glycerol. So, can you arrange it in decreasing order of vapor pressure? Indirectly, vapor pressure depends upon force of attraction. You can write here vapor pressure inversely proportional to force of attraction. If you don't have any idea about it, let me know. I'll tell you.
So force of attraction is more in what uh, in what in what elements?
In any compound that you are watching, like force of attraction between molecules, like if you are going for ethanol, force of attraction between ethanol molecules, force of attraction between glycol molecules, force of attraction between glycerol molecules. Got it?
No, sir. Can you say again?
Oh, see, force of attraction, that means force of attraction between molecules. If you are going to see like A or B, you are going to compare between A and B. Now see, if force of attraction is greater in A container, that means the molecules that present in A, than force of attraction in B. So vapor pressure is greater in this. Are you getting my point? Force of attraction in the molecules that you are watching or you are comparing. See, whenever you are going to arrange vapor pressure, what you have to do is you have to see which molecule will have lower force of attraction or greater force of attraction. If the molecule, the one which has lower force of attraction will have higher vapor pressure. So you can see this will make hydrogen bonding like this.
Sir,
This
how
will
do we
make,
know? How do we know if a compound has a higher force of attraction?
so you have to see which type of compound it is. Like in class 11th, you have studied states of matter and chemical bonding. Yes or no?
Yes.
So there is a hydrogen bonding which is very important. Now see, you can see. Do you know which molecule can form? What is the condition of hydrogen bonding? Do you know? Yes or no?
No, sir.
Now see, hydrogen bonding always forms with phone. Hydrogen bonding, basically it forms with generally phone. Do you know what this phone means? Phone means that means fluorine, oxygen, nitrogen. If
Nitrogen.
hydrogen is nearby FON or individually O, N or F, it will form hydrogen bond. It can form hydrogen bond. So in case of water, basically it is not actual bonding like covalent bond. You can see H2O. This is H2O. Are you getting my point? This is H2O, and these two bond that I have written in black color. This is covalent bond. Yes or no?
Yes.
So if in a container, you know that millions of molecules. If you have a cup of water, it will have millions of molecules of water. It will be, yes or no?
Yes.
Now see, if you have another molecule of water that will be present, there will be force of attraction between these. If you have another H2O molecule that you will have, there will be force of attraction like this. If you have another like this, there will be force of attraction like this. This is called basically hydrogen bonding. Are you getting my point?
Yes, sir.
Now see, this OH, like you know that only one C2H5 H5OH is not present in a cup or in a container. There will be millions of C2H5OH. in which oxygen will make a bond with another hydrogen of C2H5OH, and that will form hydrogen bonding. So it will form one hydrogen bonding, there will be two hydrogen bonding, you can understand like this, and there will be three hydrogen bonding. If bonding will be more, then force of attraction will be also more. Yes or no?
Yes, sir.
So if force of attraction is more, then vapor pressure is less. Yes or no?
Yes.
Now you can say only one hydrogen bonding. That means it is it has force of attraction lower. That means vapor pressure is greater. In the same way, like this is our answer. There is another saying about force of attraction. You have studied probably in class 11th that molecular weight increases van der Waals force of attraction. Have you ever heard this? Van der Waals?
Yes. But I don't
Then
know what
if
it is.
basically molecular weight increases, van der Waals force of attraction increases. You can see this will have lower molecular weight as compared to this because it has only two carbon. It has also two carbon, but you can see it will have more molecular weight or not because it has only one oxygen. It will have two oxygen. It has six hydrogen. It has also six hydrogen. Now you can see there will be three carbon, three oxygen. So molecular weight in this is very high. That means force of attraction, van der Waals force of attraction is very high. Are you getting my point? You can think of like this
Yes, sir.
also. So please write it. Do you have any idea when is your paper, unit test or anything?
Yeah, sir, my term one already finished.
Oh, what was the syllabus? I want question paper.
Syllabus was first three chapters that we
First three
studied.
chapters, like tell me the chapter name, like solution, or it starts from solid state.
Haloalkanes, haloarenes.
Okay, that was the one.
Then after that, there's one chapter I forgot the name.
Alcohol, organic from organic,
Yes,
or
alcohols, ethers and phenols.
yeah, alcohol, ethers, and phenol. And the third chapter, that
And
is also from organic.
third chapter, the one which has the one which we are doing now,
Oh, solution.
solutions.
Can you send me the question paper?
Yes, sir. I'll ask the question paper, then I'll send you when I get it.
Okay, please do it.
Okay.
Okay, let me know when you are done with this. I'm waiting.
Okay. Okay, sir. Then.
Done. Hamza, done.
Yes, sir.
Okay. Now we are going to start new topic. Now see substance. First, we are going to see how many types of substance are there in on the basis of vapor pressure. So there are two substances. One is volatile substance, and the another is non-volatile substance. Non-volatile substance. See, volatile substance, that means this type of substance basically has some vapor pressure that will create some vapor pressure. That means vapor pressure not equals to zero. But when we talk about non-volatile solute, it means this will not create any type of vapor pressure. Vp will be zero in case of non-volatile substance. Now I'm going to take some examples like H2O is volatile, CH3OH methanol is volatile, CH3 CH2OH is volatile, etc. are types of volatile substance. But when we talk about non-volatile substance, I'm going to take example like glucose is non-volatile, urea is also non-volatile, sucrose is non-volatile. That means if it will present in a solution or anywhere, it won't create any type of pressure, vapor pressure. It won't create any type of vapor pressure. I'm going to write the formula of this HC6H12O6. Urea has a formula NH2CO NH2, and sucrose has a formula that means sugar C12H22O11. Also, it is very important to note that if you have remember or you already know the atomic molecular mass, it has a 180 gram, it has 60 gram, and it has 342 gram. It is not necessary to remember it, but if you know it from beginning, it will be helpful for you to calculate the numerical fastly. So this is the type of substance that is volatile and non-volatile. Let me know when you are done with this. I'm going to plot a graph, which is very important graph, vapor pressure versus temperature. So I have a question. Vapor pressure, that means liquid is converting into vapor, that means gas. You know that every substance that exists has some boiling point. Are you getting my point? What is boiling point, Hamza?
Yes, sir.
Boiling point is the temperature at which something evaporates in liquid, something from liquid. It is uh, changing its state from liquid to gas. Wait a minute. Now see, the graph is basically vapor pressure or temperature will be like this. With increasing temperature, the vapor pressure will increase, and a time will come when the temperature will be constant. That means it is the temperature at which all the substance will be converted into vapor. Is that clear, Hamza?
Yes, sir.
Just like you can take example like if you are going to boil water, just you just give start giving heat, and a time it will start heating, and a time will come when it the heat will give uh, produce temperature at 100 degrees centigrade, and at 100 degrees centigrade all the water molecules will be converted into vapor. That is water vapor. So please plot the graph and let me know when you are done with this. Let me know when you are done with this.
Okay. Done, sir.
Now see, are you aware of volatile and non-volatile? Whenever I will use non-volatile, that means there will be no vapor pressure due to the presence of that substance. And if I'm using volatile, that means it will create some vapor pressure. Okay, so please keep it in mind. Now see, there is a topic related to this. Now we are going to introduce Raoults law. Before that, vapor pressure of solution containing two volatile liquids containing two volatile liquids. So if we are talking about solution, that means if we are talking about solution, that means there is solute and solvent. The component is solute and solvent, and both are basically volatile liquids. That means both will create some vapor pressure. So I'm going to take a container A in which only A is present. Wait a minute. In which only A is present. You can see this container will have only A, that means pure A. You can call it pure A because only A is present here. And another container B, you can take B as solute. So only B is present, that means it will have pure B. Now going to mix it to form a solution and keep it in a bigger container. That means A, B, A, B. This is solution. Now see, whenever I will say only A is present, that means pure A. So we will represent it by P naught A. That power is represents pure. So P naught A, I'm going to write it here. Pure liquid A, that means only A is present. Pure liquid B, that means only B in this container, only B is present. P naught A, that represents pure vapor pressure, pure or vapor pressure of pure liquid A. Pure liquid A. In the same way, this is pure, that means we will represent it by P naught A, and it means vapor pressure of pure liquid B. Pure liquid B. And again, if you are going to see the bigger container which contains the solution will have A, B, A, B, A, B. This will have both, that means A, B, A, B, A, B. That means this will, and both are volatiles, that means both will create some vapor pressure. So we will represent PA and PB. PA, that means partial pressure of A, partial pressure of A, or you can call it partial vapor pressure of A, partial vapor pressure of A, or you can also call it partial pressure of A. And PB, that means partial vapor pressure of B, partial vapor pressure of B. So is there any doubt in this representation? Hamza,
Yes, sir.
is there any doubt in this?
No, sir.
Now see, if I'm going to ask you, what will be the mole fraction of A here? So you know that mole fraction of A will have a formula, number of moles of A upon total number of moles. This is the formula for mole fraction. Yes or no? Tell me.
Yes, sir.
So you know that in this container, number of moles of A is just suppose Na, and total number of moles is basically only A present. So Na will have a value 1. So whenever a pure container, a pure something is pure in container, that will have a mole fraction 1. And also mole fraction of B. Now you know that mole fraction of B is 0 here because no B is present here. There is no B. That means mole fraction of B is 0 for this container, left one container. Now when we talk about B container, mole fraction of B will be 1 and mole fraction of A will be 0.
Okay, sir.
So please write it, and then we will introduce Raoults law on this, which is very important. Let me know when you are finished with this.
Done, sir.
Very good. Now see, I'm going to introduce. Okay, there is a question. If any substance has more vapor pressure, that means force of attraction is less or more. Hamza, if any substance has more vapor pressure, that means force of attraction is less or more.
Sir, can you say the question again?
If any substance has more vapor pressure, that means force of attraction is less or more.
More vapor pressure means less force of attraction.
Force of attraction. So see, if less force of attraction, then boiling point will be lesser or no. Lesser or more. Boiling point will be high or low.
Boiling point will be low.
No.
No,
See,
high.
yes. If vapor pressure is higher, that means force of attraction is lower. That means if force of attraction is lower, that means it will be easily convertible in vapor. That means boiling point is high. That means basically vapor pressure inversely proportional to boiling point. We can also write. That's why see, C2H5OH ethanol has more vapor pressure than water. That's why C2H5 has lesser boiling point than water. Are you getting my point? Yes, Samja, are you getting my point?
Yes, sir.
Okay. Uh, can I change the slide?
Done.
Very good. Now see, we are going to introduce Raoults law. Raoults law. What is Raoults law and all? So I'm going to define it first. Then I will explain. According to this law, in a solution, partial vapor pressure of each component is directly proportional to mole fraction of that compound. Mole fraction of that component, sorry, not compound. If we are talking about only compound, then component. That's why I wrote it here, component also. Now see, according to this law, in a solution, partial vapor pressure of each component is directly proportional to the mole fraction of that component. You can see it is talking about the solution. In a solution, partial vapor pressure of each component in a bigger container in which A and B both are present, in which PA is the partial pressure of A, and PA is basically directly proportional to mole fraction of A. Are you getting my point? This is the statement that we are writing in mathematical equation is given by Raoults. Hamza.
Yes, sir.
Now see, to remove this proportionality sign, I am going to introduce a constant that is K into zeta. K is basically constant. K is basically constant. Now, what is this constant? I am going to derive another what is basically constant. So to find the value or to calculate the value of K, what is basically K, we are going to assume if A is pure. I'm going to assume if A is pure. If A is pure, that means mole fraction of A will be equal to 1. Yes or no?
Yes, sir.
Hamza? Now see, I'm going to put the value of zeta A, that means mole fraction of A. PA will be equal to K into 1. Also, PA is equal to K. That means here the A is pure. And you know that whenever A is pure, we use P not A. I told you that whenever A is pure, we use P not A. PA is basically partial pressure of A, and P not A is vapor pressure of pure liquid A. Is that clear? So here is the value of K. Here is the value of K. So I'm going to put the value here at the place of K, and we will get a formula PA is equal to final formula P naught A zeta. There will be no question on derivation of this formula, just for the concepts and how we got the value of P naught A. I just explained it. What you need to learn is partial pressure of A will be equal to pure pressure of A into mole fraction of A. Is that clear, Hamza?
Yes, sir.
Now I can also write in the same way, PB will be P naught B, pure, partial pressure of B is equal to pure pressure of B into mole fraction of B. So please write it. I'm going to write all the PAs, partial vapor pressure of A, PB is partial vapor pressure of B, zeta A is mole fraction of A, zeta B is mole fraction of B. Please write it.
Done.
Very good. Is there any doubt in this?
No, sir.
So see, there is a formula PA is equal to P naught A. What you have to learn is here PA is equal to P naught A zeta A, PB is equal to P naught B zeta B. Now we are going to apply Dalton's law in this law, which is very important. You know that basically in this container there will be PA that will be equal to P naught A zeta A, and there will be PB that will be equal to P naught B zeta B, and there will be a total pressure PT in this container. So we are going to talk about PT, that is total pressure. So for total pressure, I'm going to introduce the formula you have studied in class 11, that is Dalton's law of partial pressure. Dalton's law of partial pressure. What Dalton's law of partial pressure says that total pressure will be equal to sum of all individual partial pressure. Sum of all individual partial pressure. Sum of all individual partial pressure. So you can see that in the solution only A and B is present. and A has a partial pressure that is PA, and B has a partial pressure that is PB. So what will be the total pressure? PT will be equal to this. PT is equal to total pressure. Total pressure, and you can also call it total pressure of solution. Pressure of solution. So whenever we talk about PT will be equal to PA plus PB, partial pressure of A plus partial pressure of B. Also, PT is equal to PA, that means P naught A zeta A, P naught A zeta A plus P naught B zeta B, P naught B zeta B. This is the formula for total pressure, the final formula of Raoults law. We will have some question on this, and there will be graph, which is important. The question is purely on the formula. If you know how to calculate mole fraction, let me know when you are done with this.
Done, sir.
Done, very good. Now we are going to have a question on this topic, which is very easy. If you know how to calculate mole fraction and all. Whenever you are going to solve question, first omit what is given in the question and then see what it is asking. Just write the formula and try to fit whatever is the given in the question, and you will get your answer easy. At first, you will take some time to calculate it, but at last, it will be very easy. If 0.78 gram of benzene, do you know what is the formula of benzene?
It's C6H something. No, 1 minute. Let me check, sir, again.
Okay, where you need, is it? Wait a minute, I'll talk to you. Toluene. Toluene has a formula that is C6H5CH3 are mixed. Find partial pressure. Just write the question. Partial pressure of
Okay, sir.
benzene and toluene. And also total pressure. Also there will be given P naught B, that means pure pressure of benzene is 400 mmHg, and P naught T, that means pure pressure of toluene is 200 mmHg. QNL, what does this mean? QNL.
Sir, can you solve this one?
Yes, yes. See, I think you are in hurry, right?
Yes, sir.
Okay, so we see only this question, then we will have class by tomorrow. Okay. Now see, we need to calculate partial pressure of benzene, and partial pressure of benzene. If I'm going to represent this small b that represent partial pressure of benzene, there will be a formula: pure pressure of benzene into mole fraction of benzene. Yes or no?
Um, sir, what?
There was a, you know that PA is equal to P naught A zeta A. This was
Yeah,
the
that's the
formula.
formula. Yeah, yeah.
Yeah, for A. Now for B, benzene, B for benzene.
Yeah.
Partial pressure of benzene will be equal to pure pressure of benzene into mole
Two.
fraction of
Yes.
benzene.
Yes.
Now you know that it is already given, yes or no? So I can put the value
Yes.
400, and you can calculate mole fraction of benzene also. Mole fraction of benzene will be equal to number of moles of benzene upon number of moles of benzene plus number of moles of toluene. Number of moles of benzene, that is given mass upon molar mass. You know that given mass is
Yes.
0.78. And if you are going to calculate molar mass of benzene, it will be 78. Again, 0.78 upon 78 plus number of moles of toluene, that will be equal to given mass 0.92 upon molar mass of toluene is basically 92. Now you can easily cancel it. If you are going to remove the decimal, it will be 100 multiplied by 100 and 78 cancel. If you are going to remove the decimal, it will be divided by 100 and this will be cancelled. Again, if you are going to remove this decimal, it will be divided by 100 and this will be cancelled. What we got is 1 by 100, that means 0.001. Sorry, 0.01. 0.01. Again, here we got 0.01 plus 0.01 because everywhere 1 by 100. So what we got is 0.01 divided by 0.02. If you are going to remove this decimal, it will be 1 by 2 will have. This is the mole fraction of benzene. So I am going to put the value P naught B has a value 400 into 1 by 2, that will be equal to 200 mmHg. Are you getting my point?
Yes, sir.
Now, in the same way, you can calculate Pt is equal to P naught T, that is given in the question, and mole fraction of T you can put here. Okay, and for total pressure is equal to whatever is the value of partial pressure of benzene and whatever will be the value of partial pressure of toluene, you will get your answer when you will add it. So please write it. So by tomorrow, can you arrange the question paper?
Sir, done.
Okay. So is it compulsory to go? Hamza Sekhani?
No, sir. I can finish this class.
Okay.
I was just asking when it will finish.
It will be finished by 8 before it is. Is there any important?
No, sir. Just asking when this will finish.
Okay. The class? When will class finish? Okay. So basically, our class is always for 1.5 hours. Okay.
Yeah, okay, sir.
Okay. Can you solve this P not PT? I was thinking that you will go right now. Can you solve this?
Yes, sir. 1 minute.
Okay, please do it. It's very important to solve it right now so that you will. I'm going to give you another question on this topic. Then we will do a graph. Very easy question. Is it done or do you need any kind of assist?
No, sir, I'm doing 1 minute.
Okay.
It will be 90.
It is 90 pt.
Yes, sir.
Now see, have you calculated this value? This was 200 mmHg, right? PB.
Yes, sir.
If we are going to talk about PT, this will be equal to P naught T into zeta T. P naught T has a value 200 that is given in the question, yes or no?
Yes, sir.
What is the mole fraction of toluene you have calculated? What is the value of xt zeta T? Hamza,
Yes, sir. So
what is the value of
0.5, 1 by 2.
0, 0.5 by 2?
1 by 2, that is
1
0.5.
by 2. Yeah, 1 by 2. So it will be 100 now, 90 or 100.
Yes.
And now you are
90.
going to talk about PT, total pressure. That will be equal to partial pressure of benzene plus partial pressure of toluene. So partial pressure of benzene, I just calculated 200 and partial pressure of toluene, that is 100. So it will be 300 mmHg. This is our third part's answer. Okay. Hamza.
Yes, sir.
Okay, just write it and let me know when you are finished. I will give you another question. Are you done with this? There is a solution in which ethanol plus methanol is present. Ethanol has 3 mole and methanol has 2 mole. Also, it is given that pure pressure of ethanol is 60 mmHg, E for ethanol, and pure pressure of methanol is 50 mmHg. This is the question given. Now, calculate partial pressure of ethanol, partial pressure of methanol, and total pressure or pressure of the solution. This is 3 part you have to solve. Let me know if you have any doubt. Can you solve it?
Yes, sir. Sir, I don't know how to solve it.
You don't know.
No, sir.
It's very bad, Hamza. I just gave you the question easier than the previous question. You
Sir,
know what? Yes, yes. What is the problem? Tell me.
um,
See, ethanol and methanol is present. Okay. Mole of ethanol is this much. Methanol is this much. Now, pure pressure of
wait, yes,
ethanol is given.
yes. Yeah, sir, I understand.
Pure pressure of methanol is also given. Now you have to calculate to partial pressure of ethanol, partial pressure of methanol, and total
Yes.
pressure. Please attempt it. Let me know if you have any problem.
Sir, 110.
Which you solved PE,
PT, sir.
PT, total pressure.
To do PE plus PM, right?
Yes, first partial pressure. This, if you have problem, I'm going to write partial pressure,
Yes, partial pressure of ethanol.
ethanol. What is answer? Partial pressure of methanol. Please solve all three questions, then let me know the answer. Hmm.
Sir, the partial pressure is 60 mm Hg, right?
No, no. This is the pure pressure of not. There is not present. Now, pure pressure of ethanol.
Okay, okay.
So, what is the formula? Partial pressure of a substance is equal to pure pressure of that substance into mole fraction of that substance. Got it?
Yes, sir.
Okay, please solve it. If you still have any doubt, let just ask me. Let me know.
Sir, mole fraction of ethanol is 0.25, right?
You just have to put it in ratio. Mm, Sorry, fraction. So if you are going to calculate mole fraction of ethanol, number of ethanol 3 upon total moles, that will be 5. Mole fraction of ethanol will be number of moles of ethanol upon total moles. Are you getting my
Yes.
point? 3
Yes.
by 5 it is. Can you solve it or I should help you?
Sir, I'm trying 1 minute. Sir, can you do it?
Yes. See, what is the question? We need to calculate partial pressure of ethanol. So PE will have a formula P naught E into Zeta. This is the formula, so simple. So partial pressure of ethanol, what is the value? P naught E has a value 60 into mole fraction, that is 3 by 5. So basically it will be cancelled by 12 times and it will have a value 12 into 3, that is 36 mmHg. Again, PM will have a formula P naught M into zeta M. So PM will be equal to P naught M has a value 50 into mole fraction. If you are going to calculate mole fraction of M, given number of moles of methanol upon total moles. So it will be multiplied 10, 10 3 30 mmHg. Now, if you are going to calculate total pressure, so total pressure will be partial pressure of ethanol plus partial pressure of methanol. So 36 plus 30 will be equal to 66 mmHg. Is this tough? Is it easy or tough?
It's easy, sir.
So easy it is. Let me know when you are done with this.
Done, sir.
Very good. Now we are going to see a graph, which is very important. See the graph. The graph is like this. Now see, this is basically pure A, here pure A, and here it is pure B. And this X represent mole fraction, and this is basically vapor pressure. Now see, if only pure A is present here, that means mole fraction of A will be equal to 1 and mole fraction of B will be 0. In the same way, mole fraction of B will be equal to 1 and mole fraction of A will be 0 because there is no A and there is no B. Now see, we know that PA is directly proportional to mole fraction of A. So it will be like this and this will be like this. Since pure A, so it will be P naught A. Since pure B, it will be P naught P. And PB is equal to P naught B into zeta B is this graph, and PA is equal to P naught A zeta A this graph. And if you are going to join this, add this PA and P naught B, it is a straight line. It is a straight line like this. This represent basically PT, that means total pressure is equal to partial pressure of A plus partial pressure of B. Please write it and let me know if you have any doubt.
Sir, done, sir.
Very good. Now see, an important question on this topic. If I'm going to give you similar question, just want to know whether you got it or not. Just try this. Is your marks declared of the last test, unit test? How much you got?
Sir, unit test is over.
Mm,
No,
No, the result about.
result of half term did not come out yet.
Okay. This is the question. Please do it. It is same like previous question. Can you do this or you need
Yes, sir, I can do
help?
this 1 minute.
Okay, please do it. Electricity is cut off, that's why I'm looking so tight.
Sir, is partial pressure of four
Wait a minute. It is the question is not complete. Sorry. P naught B is given as, and this is toluene for, and we cannot calculate without this. What was your
That'll
answer?
be 60 for
Of what?
benzene. Benzene.
Benzene.
Yes, sir.
See, for benzene, Pb will be equal to P naught B into ZW. And you know that this is a value 100.
100
And what
into
is the mole fraction that you calculated?
0.6.
0.6 mole fraction of benzene.
Yes, sir.
That's correct. Mole fraction of benzene will be equal to number of moles of benzene upon number of moles of benzene plus number of moles toluene. Now, number of moles of benzene is equal to given mass 7.8 upon molar mass, that is 78 upon 7.8 upon 78 plus given mass 9.2 upon molar mass 92. Again, if you are going to remove this decimal, it will be divided by 100 in the same way everywhere. 100, 10, and it will be divided by 10. And now you can say 78, 78, 78, 78, 92, 92 will be cancelled. 1 by 10, that means 0.1 upon 0.1 plus 0.1. So basically it is 0.1 by 0.2. We can cancel this decimal and it will be 1 by 2. How
Sir,
can you calculate it?
sir, 1 minute, sir. I'll be back after 5 minutes. I need to go to
Uh,
the bathroom.
Okay. Hamza? Hamza, are you there?
So I'm back.
Okay. So this you will attempt from home.
Sir,
We'll see
your
you
voice
tomorrow.
is
And if
breaking.
you, Hamza, please do this question. Am I audible?
Yes, now you're audible, sir.
And please arrange previous year's question or the unit test you had given. Please arrange that question paper. Okay.
Yes, sir. I told one of my friends.
Okay. Thank you so much